Okay. So we're continuing on operations with radicals. Today we're looking at multiplication and division, which is a little bit more complicated than adding and subtracting, but not too bad. It's actually pretty fun, relatively speaking. All right, so if we start with multiplication, real straightforward. As long as you have the same index, we can just multiply everything together. So all of your coefficients you can multiply together. Everything under the radical, you multiply all that together, and then the index stays the same. So I can take the cube root of something times the cube root of something else. I just multiply everything together. Okay. So two ways we could look at this. I know 5 times 3, I'm going to have 15 on the outside. But what catches my eye is I see negative 12 and 18. And I think I don't really want to have to multiply 12 times 18 and then take the cube root of that, right? So instead of just multiplying those together, I'm going to try to break that down first. So I know negative 12 is, I know there's a negative 1. I can take the cube root of that, right? And then 12 is 4 times 3. And 4 is just 2 squared times 3, right? So that's negative 12. Negative 1 times 2 times 3. I'm going to bring the rest down, AB squared. And we'll leave that in our cube root. Okay? And then I'm going to do the same thing for my second term here. So 3 on the outside, third root of. So 18. 18 is 9 times 2, or 2 times 9, or 2 times 3 squared. Okay? And then A squared times B squared. So I haven't changed anything. All I did is I broke down the coefficients under the radical. So now I'm going to multiply everything. Okay, so on the outside, 5 times 3 is 15. Okay, cube root. So I only have one negative 1, so I'm going to leave that as negative 1. I've got 2 squared times 2 over here, so that's 3 2s, so that's 2 to the third. And then I have, let's go purple, I've got 3 times 3 squared, so that's 3 3s, so that's 3 to the third power. And then the variables is nice and easy. A times A squared is A to the third. B squared times B squared is B to the fourth. Okay, and now that's what I'm looking at. So now, once I have everything multiplied together, your last step is always going to be, can I simplify the radical? And this is where all this prep work we did up here pays off, because now I already have everything separated out. And since it's the cube root, I can say anything that I have at least to a power of 3, I can take the cube root of that. And that also includes negative 1. We can always take the cube root of negative 1. So I know I have, how do I want to do this? Let's put everything out here. So negative 1, put that first, then we have 15. 2 to the third power, the cube root of that is 2. Back to purple. The cube root of 3 to the third is just 3. The cube root of A to the third power is just A, right? The cube root of B to the fourth, we know we're going to have B on the outside, but there's actually, and this is the only thing that's left over under our cube root, is we have this 1 left over B. Okay, and probably, let's see if we can't space this out. Oh no. Sometimes it kind of looks like put B to the third, when really that's the cube root of B. Okay. Then I take all my numbers here, multiply them together. So 1 times 15 times 2 times 3 is negative 60. AB to the cube root of B. Not sure why I keep making that so big. And there's our answer, which was a lot more work than it might have needed to be. So, yeah, let's actually do one more of those so you can see a little bit easier version of this. So let me go ahead to, let's do one of the easy ones here. All right, so if we do number 7, right, nice and simple. 2 square roots, so I know I can multiply them together. I can multiply everything on the outside first, so we just have -4 and 1. So that's -4 on the outside. Under my square root, 3 times 8 is 24. And then my variables, n squared times n squared is n to the 4th. And then we just need to simplify 24 n to the 4th. So this would be square root of 4 times the square root of 6. And then the square root of 4 is 2. So I know I can take the square root of 2 out. So -4 times 2 is -8. I still have, oh wait a minute, leave some space here. So we still have the square root of 6 inside of our radical. And then n to the 4th, right? 4 divided by our index of 2 is 2. So the square root of n to the 4th is n squared. There's no remainder, so there's no n left in my square root. So then this becomes our answer. There it is. Okay. So this is a lot more straightforward if our numbers are smaller. The bigger the numbers, the more work we have to put into simplifying our roots. Okay, so that's multiplication, not too bad. The more difficult one is there an order? Okay, is division with radicals. Okay, so a couple things to keep in mind. The big one being you cannot leave, get rid of this box. I don't want this box here. Come on, there it is. Okay, we can't leave a square root or any kind of root in the denominator. So always keep in mind, we cannot end with a root in our denominator. If you see any answer choices that end with a root in the denominator, cross it out, can't be that. Okay? So the first thing you always do, you look at your problem, you say, can I simplify this at all? You always want to simplify before you do anything extra. The simpler we can make our original fraction, our original division problem, the less work we're going to have to do later on. In this case, all I have is y to the 7th, x to the 6th. I can't do anything with that because they are different variables. So our second step, if you have a root going over the entire fraction, you can always rewrite that. Go back to my marker. By separating it into top and bottom. Okay. Let's see, if we're just doing square root, or actually, there's 2 ways we can do this. Let's do it one way, and then we'll show you an easier way that involves a little bit of thinking. Okay, simplest way to get rid of a radical in your denominator, if it's the square root, to just multiply it by itself, right? Any number times itself will get rid of the square root. And in order to keep that from changing the value, I need to multiply the top by the same amount. Okay? So then we multiply straight across. So we can multiply these, we just said, right? Since they're both square roots, I can just multiply everything on the inside. So that's just y to the 7th, x to the 6th over. And then this becomes, remember, any number times itself. If it's a square root, you end up with just that without the square root sign. All right? So now we have y to the 7th over x to the 6th divided by x to the 6th. And then we just need to simplify from there. So can I take the square root of x to the 7th? Yes. So 7 divided by 2 is 3. So I can say y to the 3rd. And then we have 1y left over. And then for our x, 6 divided by 2 is 3. So you can say x to the 3rd, nothing remaining there, over x to the 6th here. And then we say, can I simplify my fraction? So since I have x divided by x, remember our old rules, right? If you're dividing with powers, you just subtract So 3 minus 6 is -3. So y to the third over x to the third. Don't forget your square root here. And then this becomes our answer. Like I said, it's a bit more work than multiplication. Okay. So what else could we have done? I said there's another way. We could have gone back to the very beginning here. It's not as much fun in showing how rationalizing the denominator works. But we did say to try to simplify as much as we can at the beginning. And can we take the square root of x to the 6th? And you'd say, oh yeah, because 6 divided by 2, that'll just give us x to the third here. And then we can just simplify our numerator. So that would give us our, oops, not 3y, but y to the third with y left over. And suddenly we're done, right? Hooray, we got the same answer we did before with a lot less work, but a lot less practice. Okay, let's go to the next one. That's not the next one. This one. Nice and easy. 5 divided by square root of 3. So I can't simplify that at all. There's no shortcuts here. So I'm going to rewrite it. So 5 over square root of 3. I want to get rid of this root in the denominator. So I need to multiply top and bottom by the square root of 3. So on the top is just 5 square root of 3. Square root of 3 times square root of 3 is just 3. And then from here, can I simplify this at all? Not so much. So then this becomes our answer. Okay? So in the simplest problems, when you rationalize the denominator, if it's just a single number, you're always going to end up moving that root to the numerator, and then you're going to have the radicand, the number under the radical, will end up as your new denominator. Okay? All right, one more. This is the tricky one. So 7 over the cube root of -2. That's the operative word here. So I can't simplify that at all. It's like 7 over the cube root of 2. So what makes this a little bit different is, like last time we said we wanted to rationalize, and we just said, oh, we'll just multiply by itself, and that was good enough. But is that true here? If I just do 2 times 2, now I have the cube root of 2 squared, and I don't know what the cube root of 2 squared is, right? So in order to simplify this one, to get rid of this radical in the denominator, since it's the cube root, I need 3 2's. So I would either need to multiply by the cube root of 2 again, or cube root, right? Because then all of this would equal just 2. If you don't want to have to write out that much, you can get the exact same effect. Instead of putting 2 times 2 again, we could just say this has to be times 2 squared, right? So then we have 2 times 2 squared. That gives us 3 2's again. That's what we need. Okay, so then we put it all together. So 7 times the cube root of 2 squared. And then at this point, let's work that out. So 2 squared is just 4. So I can say 7 times cube root of 4 over. And then we said the whole point of doing this was that we end up with just 2 in our denominator. Then we check to see if we can simplify. I mean, technically we could say 7 divided by 2 is 3.5, but let's not replace fractions with decimals. Let's just leave it as a fraction. I can't take the cube root of 4, so this becomes my final answer. Okay? So be very careful when you have a cube root in the denominator, because then you need 3 of your radicand in order to drop the root. And then if it was the 4th root, then you would have needed 4 2's. Okay? So be careful when you're dealing with things other than square root, but mostly have fun with it. It's like problem solving or puzzle solving. So good luck with it. Let me know if you have questions.